Here's what no one tells you about the universe. Every equation, every telescope, every satellite we've ever launched into the dark, they all point to the same terrifying conclusion. Our universe should not exist. Not in the poetic sense, in the mathematical sense. The conditions required for stars, atoms, and life to form are so precise, so absurdly, almost offensively precise, that physicists call it the fine-tuning problem. And for decades, it was a quiet embarrassment, hidden in footnotes, avoided at conferences. Until Carl Sagan asked the question no one else dared to say out loud. What if our universe isn't the only one? That idea, 6 words, nearly split cosmology in two, and we still haven't recovered. His name was Alan Guth, and in 1979, he was a nobody. Not metaphorically. He was a struggling postdoc with no permanent job, watching his peers get positions while he collected rejection letters. On the night of December 6, 1979, unable to sleep, then he sat at his desk and wrote a calculation that would change everything. He called it inflation. The idea was this: in the first fraction of a second after the Big Bang, not a second, not a millisecond, but 10 to the power of negative 36 seconds, the universe expanded faster than light. Not matter moving through space, space itself stretching. It solved 3 massive problems in cosmology simultaneously: the horizon problem, the flatness problem, the magnetic monopole problem, by problems that had plagued physicists for decades, erased in a single night's work. Guth wrote in his notebook, "Spectacular realization." But there was a consequence, a side effect no one asked for, a dark implication buried in the math. If inflation happened once, it almost certainly never stopped. Inflation, once started, becomes eternal. Quantum fluctuations keep triggering new inflationary regions, forever, in an endless cascade of bubble universes, each one sealed off. Each one potentially with different laws of physics, different constants, different versions of everything. This is the multiverse, and Carl Sagan was paying close attention. Stop. Look at your hand. The distance between your outermost electrons and your nucleus is, proportionally, the same as the distance between the Earth and the Sun. You are mostly empty space, held together by forces so finely tuned that if the electromagnetic constant shifted by 1 part in a trillion, your hand would dissolve. Someone or something set that number, or the universe set it itself. Which answer frightens you more? Here is the problem Sagan could not shake. The universe runs on about 20 fundamental constants: the speed of light, the gravitational constant, the mass of the electron, the cosmological constant, Einstein's biggest blunder, which turned out to be real and which controls how fast the universe expands. Change any one of them by even a fraction, and you don't get a different universe. You get nothing. No stars, no chemistry, no time long enough for complexity to emerge. The cosmological constant alone is tuned to 1 part in 10 to the power of 120. That's not a number. That's a provocation. Physicists call this fine-tuning. Theologians call it design. But Sagan refused both answers, but not out of arrogance, out of rigor. He wrote in The Demon-Haunted World, "Science demands that we accept uncomfortable answers, not comfortable ones. And the multiverse, as philosophically nauseating as it felt, was the only answer that didn't require a miracle. If there are infinite universes, each with randomly assigned constants, then of course some will hit the configuration required for life. And of course, only in those universes will anyone be around to notice the coincidence. We don't live in a special universe. We live in a survivorship universe. This is called the Anthropic Principle, and it is either the most profound idea in the history of science or the most elaborate excuse for not having an answer. Even physicists disagree. Violently. In 2007, physicist David Guth, Nobel laureate, stood up at a string theory conference and said the multiverse was giving up, that it made physics unfalsifiable, that it was, in his words, a fantasy. In the same room, physicists who had spent their entire careers on it. The applause was split exactly down the middle. That's where cosmology stands today. Not at the edge of an answer, at the edge of a war. Carl Sagan didn't invent the multiverse, but he did something more important. He asked what it means. In Cosmos, he described the universe as all that is, or ever was, or ever will be. At the time, that felt like poetry. Now, the physicists are asking whether that sentence is literally false. Sagan's real contribution to this debate wasn't a paper. It was a framework for thinking. He insisted that extraordinary claims require extraordinary evidence. The multiverse is the most extraordinary claim in human history. The assertion that everything we can observe is an infinitesimal fraction of what exists. And we have, so far, zero direct evidence. But here's what we do have. The CMB, the cosmic microwave background, the thermal echo of the Big Bang, printed across the entire sky, contains anomalies, cold spots, statistical asymmetries, features that inflation predicts and that bubble universe collisions might explain. In 2015, researchers at UCL analyzed data from the Planck satellite and identified patterns consistent with a collision between our universe and another. Consistent, not confirmed. There's a difference. We are trying to detect an infinite ocean by studying a single drop of water found on the shore. Sagan would have loved this. Not the uncertainty, the method. The act of pressing instruments against the edge of the knowable and asking, what's on the other side? One more thing before we reach the end. If the multiverse is real, if there are infinite universes with every possible configuration of constants, then somewhere out there, there is a universe where you made every right decision, where the people you lost are still alive, where every probability collapsed the other way. You will never reach it. You cannot communicate with it. It might as well not exist. Does that comfort you or destroy you? That's not a rhetorical question. Your answer reveals something about what you actually believe science is for. In 1990, Carl Sagan convinced NASA to turn the Voyager 1 camera backward, against protocol, against the wishes of engineers who thought it was a waste of bandwidth. The image that came back showed Earth as a fraction of a single pixel suspended in a sunbeam. He said, "That's here. That's home. That's us." Now expand that thought to its logical conclusion. If the multiverse is real, then our pale blue dot is not just small within a vast universe. It is a single point of light within an infinite architecture of universes. Most of them dark, cold, lifeless. Their constants set wrong. Their stars burning for no one. Their atoms never assembling into anything that asks questions. We are not the center of the universe. We already knew that. But we might be something stranger. We might be one of the vanishingly rare addresses where the laws of physics accidentally wrote themselves into a form that could look back and be curious about the writing. Sagan called this the pale blue dot perspective, not a reason for despair, a reason for radical responsibility. Because if we are one of the improbable accidents, if consciousness is a statistical rarity written into the foam of infinite possibility, then what we do with it matters precisely because it so easily could not have happened. The multiverse, if true, does not make us less significant. It makes every moment of clarity, every experiment, every question a child asks about the sky. It makes all of it astronomically more precious. We don't know if other universes exist. We may never know. But the act of asking, of building instruments sensitive enough to look for the bruise left by a collision with another cosmos, that act is what Sagan meant when he said science is not just a body of knowledge. It is a way of thinking. And the most dangerous thing we could do, in the face of uncertainty this vast, is to stop. If you feel that curiosity is the only real tool we have against the chaos of existence, you already know what to do.